Dear students, today we are going to see the another distribution under discrete probability distribution, which is Poisson distribution. So in the previous class we have seen about binomial distribution. I hope that you can understand well and you have finished all the homework related to the problems in binomial distribution. So today I am going to explain you the Poisson distribution. So in our presentation, today's objective is how to find the probabilities using the Poisson distribution. So Poisson distribution is another discrete probability distribution. It satisfies the following conditions, that is, what are the assumptions we need to take here. The experiment consists of counting the number of times an event X occurs in a given interval. The interval can be an interval of time, area or volume. So here the probability is same for each interval. Okay, the probability of event should be same for each interval, and the number of occurrence in one interval is independent of the number of occurrence in the other intervals. Here the probability of occurring is same for each interval. This one I already told. The probability formula for the Poisson distribution for exactly X occurrence in an interval is P of X is here I can you can have in another format also. Here P of X is given as mu power X e power minus mu divided by X factorial. So instead of mu you can have lambda also. So I will write it down now. So like this, see, e power minus lambda, sorry. So instead of mu you can write it as e power minus lambda, lambda power x by x factorial. So instead of mu you can use as lambda. That is also you can use it. So in our books and all we can see lambda instead of mu. Here in this power presentation I replace the lambda as mu. Mu is the number of occurrences. Here you can get the value for E from in the calculator itself as 2.71818. See, while calculating, in doing the calculation to find the probability of an event, you can use a calculator to calculate this probability. Okay. The next thing, so by using this formula, we are going to solve one example. The mean number of accidents per month at a certain intersection is 3. So what's this value? This is mu or lambda. Okay, you can have this lambda or mu value as 3. What is the probability that in any given month 4 accidents will occur? Okay, that x value is 4 here, will occur at this intersection. So what are the given values? You need to write down first. Here the x value is 4 and mu value is 3. So to calculate the probability of an event under a Poisson distribution, the main thing, this is the parameter we need it. Okay, and this is the question they will ask. So this value is needed to find the probability under Poisson distribution. So substitute these two values in the formula. So by using calculator you can get this value as 0.168. Okay, so I have given one, I had explained one example here. Now we are going to do some try to yourself section for more practice on Poisson distribution. The mean number of customers arriving at a bank during a 50 minutes period is 10. So the mu value is given. Find the probability that exactly 8. Exactly 8 means here the x is equal to 8. So we need to find the probability for x is equal to 8. Actually our formula is e power minus lambda, lambda power x by x factorial. But here the lambda is given as 10 Okay, substitute here as e power minus 10, 10 power x value is 8 divided by 8 factorial. So use your calculator and find the probability that exactly 8 customers will arrive at the bank during a 15-minute period. Okay, do it. The answer for this is 0.1126. Whether you are getting or not, please check it. Okay, students, I'm going to the next problem. So here we finish. So we will do some more problems from the textbook. Okay, so today's session is over. We will see in the next class. See you. Bye bye.